As an example, let us look at the model of this 4-bar linkage. Here this is the one of the link which is connected to the fixed hinge, this is another link which is connected to the fixed hinge, and this is the coupler. Our objective is to use this coupler as the desk of a writing position. Right now the desk is folded such that the student can sit here and there is enough space between his leg and the next row of desk. Now this coupler can be moved such that it comes to the writing position, and now the student can use this coupler as his writing desk. As we see, here is a stopper such that the coupler cannot move anymore, and when the job is done, he can fold this writing desk and take it away while leaving his seat. So this is a motion guidance problem that I want the coupler of this 4-bar linkage to move from this configuration to this configuration in a prescribed manner. There is no need to coordinate this movement because our objective is to have it locked at the writing position and we can take it away to the folded position. So this is the example of a guidance problem or a motion generation problem without any coordination with the input movement. Next we see the model of another 4-bar linkage which is used as a tipper dumper. Let us now look at the model of this tipper dumper. Here the dumping bin is the coupler of a 4-bar linkage consisting of this yellow link and this green link. This yellow link is connected to the fixed hinge mounted on the body of the truck. Similarly, this green link is connected to the fixed hinge which is mounted on the body of the truck. So of this 4-bar linkage, this dumping bin becomes the coupler. Our objective is to make this dumping bin move in a prescribed manner from this transport configuration to this dumping configuration. This 4-bar linkage is driven by a hydraulic actuator such that link 4 is used as the input link and it is moved by this hydraulic actuator to move the dumping bin. This is again a guidance problem that I want to guide this particular coupler from this transport configuration to say this, then this, then this, and finally to the dumping configuration. So this is again a motion generation problem without any coordination with the input movement. We then will see another model of a little more involved linkage with the guidance problem. That will be the model of a rail-less garage door. Let us now look at the model of this 6-link mechanism. Here we have the fixed link 1, then 2, 3, 4, 5, 6. So this is a 6-link mechanism, and this mechanism is mounted on the sidewalls of the garage. The car is inside the garage, this is the roof of the garage, and this link represents the door board. So while the garage is open, that is the car can go out, the door board is parallel to the roof. Now to close the garage, the door board is moved such that the garage gets closed. So this is again a guidance problem. I want this particular rigid body, that is link number 6, to move from this closed position to the open position in a prescribed manner so that it does not hit the body of the car. These mechanisms are mounted on the sidewalls, so there is no obstruction with this with the car. It is only the door board which moves inside the garage and closes the garage or opens it. The thing to note that there is no prismatic pair. The entire mechanism consists of only revolute pairs. So this is the open position of the garage when the car can move out, and the door board is parallel to the roof of the garage, and in the closed position it becomes vertical. So this movement from the vertical to horizontal position must take place in a prescribed manner. This rigid body must be moving in a prescribed manner as it goes from between these two extreme positions. So this is another example of a guidance problem. So we have seen three models to explain what do we understand by a guidance problem. That is, a rigid body, which was the coupler in case of two 4R linkages, which has to be guided in a